Recently, I was at a restaurant. They brought out a chilled glass mug, then poured a warm beer into it. At first I thought this was pretty cool. My beer is cold and all is well. Until after about 10 minutes of conversation, I noticed my beer was starting to warm up. Surely there must be a better way to chill liquids and keep them cool longer than this mug. Thus, the Thermal Mug Project was born. I and my team set out to design such a mug for anyone who loves their beverages cold and likes them to stay that way until they've finished drinking them. Experiment design is a process of planning, executing, analyzing, and reporting the data of an experiment. It is this data that reveals what is most likely true. Thus, this is called the scientific method due to the empirical nature of the process. Right now, the implementation of good experiment design will help us to create a thermal mug with superior cooling capabilities, or will show us where we failed. To use data and omit personal opinion or belief will lead us to correct answers. By learning and utilizing this process now, we will be more valuable to our future colleagues and employers because we can obtain empirical results, determine what contributes to these results, and make informed decisions on how to achieve better results. After all, this is what separates true science from alchemy. It is science that proves the world is round, that stars are not pinholes in the sky. To do proper experiment design, one must first find the why. Why are we doing this experiment? What is the purpose? Next is knowledge construction. Find out everything that's already known and applicable to our experiment. Third, make a hypothesis. What do we expect to find and why? Then, execute the experiment and record the results. This is a point where both critical and reflective thinking become vital. Do the results support our hypothesis? If not, why? What can we do better? Where might we have an error in our experiment? Lastly, iteration. The more data we can collect, the more informed we become. Iteration can sometimes lead to great discovery. In our project, we needed a base comparison. So we got a glass mug, measured its mass, then put it in a freezer of known temperature. We have a math model to predict the coldest temperature this glass can deliver. The question is, are we right? We use an Arduino board with a temperature sensor, a mechanical thermometer to check its accuracy, and a temperature-controlled room to conduct the experiment. The experiment? Take the chilled mug, pour in a measured amount of 70-degree water, and record temperature measurements every 5 minutes. We want to know the coldest temperature measured and how long it takes to come back up to room temperature. Our prototype experiment is ran with exactly the same conditions. Our hope is that our prototype will yield a lower final temperature and keep it there longer than the chilled mug. If we achieve these two conditions, then our prototype is a success. This is the Arduino equipped with an LCD screen to display temperature in both Celsius and Fahrenheit, and a potentiometer to adjust the contrast of the screen. This is a temperature sensor, waterproofed with a thin layer of clear coat. Very cheap and can be found at most stores. This is our proposed design. An outer layer for cosmetics, aerogel to insulate, a layer of water to freeze, and a thin inner wall of stainless steel to separate the ice from the consumed liquid. The same design is mimicked in the cap to give an adiabatic condition. In our first experiment with the chilled mug, we predicted a final temperature of 46.46 degrees. We measured a temperature of 47 degrees. This gave us a 0.5% error. Needless to say, we were very pleased. For our prototype, our math model predicted a temperature of 3 degrees Fahrenheit. This is assuming a perfect adiabatic environment. We knew this was unreachable. However, we hypothesized that we could get below 32 degrees. Our experiment proved our hypothesis. We reached a final temp of 23.79 degrees. But what's most impressive is that it stayed there for over an hour. In fact, at 5.5 hours, we were still at 27.27 degrees. Not bad for a prototype that cost 10 cents to build. Of course, our final product uses better materials, but the proto proves we were headed in the right direction. At the end of any project, one should look back on their experience and identify their strengths, weaknesses, and what they've learned. Our team has always been extremely adept at communication. We listen to each other, we're open to new ideas, we take risks, we trust and value each team member's input. We are skilled at knowledge construction and critical thinking. We get better results faster and are able to identify problem areas in our experimentation. We are good at organizing and executing experiments. We search for scientific explanation and strive for accurate, ethically based data. However, we could be more organized at team meetings. This would increase productivity and make more efficient use of our time. We tend to get off task in team meetings. If we could be more focused and goal-oriented, we could accomplish more in less time. We also could benefit from better documentation. We often test ideas and scrap them without documenting. Though we arrive at good conclusions, documenting on how we got there would serve us and those who view our work better. This project has taught us some very valuable lessons about experiment design. It's important to note dependent and independent variables in one's experiment. This allows for manipulation with predictable outcome. It's also important to know the assumptions of an experiment. This allows for one to have realistic expectations in their design. Thorough knowledge construction is vital. Having the best information available leads to intelligent experiments. Coupled with iteration, this leads to informative and useful data. Finally, data and evidence used in place of opinion or belief leads to truth. It can answer why something is happening or how a result can be improved. We hope you've enjoyed our presentation. Thanks for watching.